morning, dear children. Let's continue with hydrogen chapter. Today, we'll learn about exothermic and endothermic reaction and the various kinds of oxides. To start off with, let us talk about endothermic reaction. So an endothermic reaction is a reaction in which heat energy is absorbed. This is evident from a very reaction that I'm going to show it to you in video also and here also, where barium hydroxide reacts with ammonium chloride to give ammonia, barium chloride and water. We can see that during this reaction, the temperature will fall below 0 degrees Celsius.
Barium chloride, both solids, you can see. I have a watch glass with some water on it, a temperature probe, and we're going to react them together and see what happens. So I'm going to put that on top of the water just so we can see the effect and mix them together. And at this point, I'm just going to put the temperature probe on. Oops. Okay, now we've got two solids reacting together here, and all I'm going to do is mix them together. Okay, and almost instantly you can see that their state is changing slightly. If you want to go inside it, you can. They're almost clumping together and making almost like a paste. Just break down some of these lumps. And if you look at the temperature, we've already gone below 0. So this is an endothermic reaction where the products will have more energy than the reactants because they're taking in the energy from the outside surroundings. So you can see now we've actually got quite a pasty liquid, and we've also got quite a big smell going on, and that's because we have made ammonia, which we test for in litmus paper. Now sometimes this goes over 30 degrees, so we can aim for that, but as you can see now it's completely liquid, so I've got some lumps in there, and it's very cold to the point that I can now pick up the watch glass because the water has frozen.
Some other examples of endothermic reactions are nitrogen reacting with oxygen at around 3000 degrees Celsius to give nitric oxide. Now this particular reaction takes place in the atmosphere when an electric discharge which is around 3000 degrees Celsius combines nitrogen and oxygen in the atmosphere to form nitric oxide. Similarly, when calcium carbonate is heated to 1000 degrees Celsius, it breaks down to give you calcium oxide and carbon dioxide. The next kind of a reaction is exothermic reaction. So an exothermic reaction is a reaction in which heat energy is given out during the reaction. And we can see this thing in the two reactions that I've penned down over here. The first reaction is calcium when treated with water. It reacts vigorously to produce calcium hydroxide, and a huge amount of heat is given out. This can be seen in the video, adjoining video. Also, we'll see another video in which we'll see that sodium metal, when treated with water, it produces a golden yellow flame, and the compounds formed would be sodium hydroxide and hydrogen. Now this reaction can be seen as an evidence for exothermic reaction, as a huge amount of heat energy would be given out and there will be explosion over here.
Let's drop calcium metal into water. You can see it bubbles. It bubbles kind of rapidly, so you can see your first chemical reaction of the year there too. The one currently? Previous one was magnesium. This one is the calcium. Little puffs of gas being given off. What you're seeing is the water vapor. You're not actually seeing the gas is being given off. The gas is being given off as hydrogen gas.
So here I'm going to take the lithium and add that to the water. It's going to generate hydrogen gas and lithium hydroxide. So you're going to see a pink color develop here, and then you're going to see some smoke come off, and that's either lithium metal or that's lithium hydroxide coming off of there. Maybe a little bit of liquid water. But it's not as reactive as, say, sodium, so I'm going to put sodium into the next one. And the sodium is actually probably going to ignite. So you'll see some orange flame perhaps, or some sparks, or some shrapnel. And then the last one, I'm going to go ahead and put my 2 pieces of potassium in that I've cut in half. So this is less potassium than the other 2 in terms of amount. But you'll find that the reactivity is a little bit greater. Now that potassium there was quite reactive there, but the sodium sometimes will allow hydrogen gas to build up. In this case it's not igniting, but we can try adding another piece here. And we can hope that that's going to go ahead and actually send off some shrapnel and some flame.
The second method for preparation of non-metallic oxides would be direct combination with oxygen again. You can see that carbon, when treated with oxygen, or when carbon like charcoal, graphite or any carbon source is burnt in presence of oxygen, it produces carbon dioxide. This can also be seen in case of an adjoining video. The second method for preparation of non-metallic oxides would be direct combination with oxygen again. You can see that carbon, when treated with oxygen, or when carbon like charcoal, graphite or any carbon source is burnt in presence of oxygen, it produces carbon dioxide. This can also be seen in case of an adjoining video. Now let us talk about the classification. This is the last section of the chapter. So classification of oxides will produce what? There are 4 classes of oxides: acidic, basic, amphoteric and neutral. In case of acidic oxides, wherever non-metal reacts with oxygen, such as carbon react with oxygen to give you carbon dioxide, sulfur reacts with oxygen to form sulfur dioxide. Now these gases are acidic in nature. How can I decide whether it's an acidic or not? So if I introduce wet blue litmus wherever these gases are being produced, we'll see that the color of the blue litmus will turn to red, indicating that these gases are acidic in nature. Whereas in basic oxides, metal reacts with oxygen to give you basic oxides. Like for example, magnesium burns in oxygen to give magnesium oxide, which is basic in nature. Similarly, sodium, when burns in oxygen to give you sodium oxide, is also a basic nature. And how do I know this thing? The same reaction as that in acidic, but in this case we'll use red litmus paper. In case of red litmus paper, it will turn to blue. In case of an amphoteric compounds are those compounds which can react with both an acid or a base. Whenever such kind of oxides can be considered as zinc oxide, lead oxide and aluminium oxide. Am I clear? Now let's come to the last part of oxide, that is neutral oxide. Neutral as such would mean that they are not affected by the litmus paper. Therefore, neither it will turn red litmus blue or not will it turn blue litmus red. And these are carbon monoxide, nitrogen oxide, N2O, etc. Thank you.